Coming up on Destination Tomorrow, we'll take a look at NASA's new crew exploration and cargo launch vehicles. We'll also find out about an intriguing new trip to Mars called the Phoenix mission. And we will revisit the Viking mission to the Red Planet. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm KERA O'Brien. Welcome to this edition of Destination Tomorrow.
Up first, we'll take a look at the new types of spacecraft that will help us go back to the moon and onto Mars.
These new vehicles, called the Crew Exploration and Crew Launch Vehicles, are currently being developed by NASA.
At first glance, these new spacecraft look very similar to the spacecraft of old, but new hardware and material make them dramatically more sophisticated. Because the science of spaceflight hasn't changed much since we started sending humans into space, the craft's shape is still a high-tech design that combines the very best of Apollo and the space shuttle. The blunt body shape simply provides the safest, most economical means of transporting crews to and from space.
Although these new spacecraft may look similar to Apollo, they will have significant advances, including the safest, most efficient shape for going beyond low Earth orbit, modern-day materials and manufacturing processes, advanced avionics, the experience gained from more than 40 years of human spaceflight, better computers, and more crew and cargo capacity.
To help us understand how these new vehicles will work, Tonya St.ROMAIN spoke with Charlie Cockrell at NASA Langley Research Center to find out more.
During the 1960s and 70s, American spacecraft had a very recognizable shape. Large rockets with a small blunt body capsule on top. In fact, all of our early space vehicles, including Mercury, Gemini, and Apollo, were designed in a similar way. This is because the small, blunt body could easily fit on top of the rockets for liftoff. And when the spacecraft returned to Earth, that shape was well suited to safely re-enter the atmosphere. But by the early 1970s, NASA was changing its focus to include a reusable space transportation system, or space shuttle, to get crews and equipment into space. This new vehicle would remain NASA's workhorse for the next 2.5 decades. Although the space shuttle proved to be very successful in its missions into space, it was designed to only stay in low Earth orbit, not travel to the moon or Mars. Because the vision for space exploration calls for humans to go back to the moon and onto Mars, the blunt body shape will once again be used to achieve these new goals. The new vehicle is called the Crew Exploration Vehicle, or CEV, and the Crew Launch Vehicle, or CLV, may look similar to the spacecraft of the past, but these new designs are definitely cutting edge. To find out about these new vehicles, I spoke with Charlie Cockrell at NASA Langley Research Center.
Well, the CEV and the CLV are actually two different types of vehicles. The CEV is actually the vehicle that's going to carry the crew to the International Space Station and onto the moon, and also consists of what we call a service module, and that'll carry the fuel for the crew capsule to maneuver around in space. And it also has a launch abort system that will protect the crew during ascent after launch. The CLV, the rocket that we're going to mount the CEV to, and that will carry the CEV to Earth orbit. Initially, we're going to design the CLV using some components from the space shuttle fleet. There'll be some new design efforts there. And then eventually, NASA is going to design what we're going to call a cargo launch vehicle, and that will take all of the other components into space that we need to get to the moon.
Why did NASA decide on a capsule design instead of a space shuttle-style spacecraft?
Well, the space shuttle was never designed to go to the moon or to travel to other planets. It was designed only to go to Earth orbit. When we looked at what we want to do in space, we want to get crew and cargo to and from the International Space Station, but we also want to go to the moon and accomplish a goal of sustaining a human presence on the moon and also eventually get to Mars. And it turns out of all the design concepts that NASA looked at, a blunt body capsule, which is very similar to what we did in the Apollo era, is the safest, most cost-effective, and most efficient way to accomplish all of those mission objectives.
You mentioned Apollo. How will the CEV and CLV be different?
Well, there's a couple of big differences between what we're doing now and Apollo. First of all, we're going to separate the crew from the cargo components that we need to get to the moon. In Apollo, we sent up all the things that we needed to go to the moon on one big rocket. This time, we're going to send the crew into orbit in one launch. following sending the cargo up in one launch. So we're going to send the lunar lander and then all the systems that we need to get from Earth to the moon. The two are going to dock in space and then they're going to go off to the moon. What that's going to do is it's going to give us better capability to get more payload to the moon, and so we're going to enable longer stays on the moon, and we're going to eventually accomplish our goal of building the capability to have a sustained human presence on the moon.
What are some of the new design elements in the CEV and CLV?
Well, the CEV is going to have a couple of new design elements compared to what we did in Apollo. First of all, we're going to design a new heat shield so that the crew capsule can withstand the heat of re-entry, and that's going to be safer for the crew because it's going to enable us to return from the moon anytime. It's also going to have a new landing system so that we can land on dry land, in addition to being able to land on water as we were restricted to in the Apollo era. And it's also going to be a bigger capsule, so we're going to be able to take more crew to the moon. We're going to be able to take a crew of 4 and eventually a crew of 6 onto Mars.
Although the CEV may look similar to the Apollo spacecraft, there are some major differences. One difference is that the CEV capsule will be launched by a smaller rocket than Apollo because it will not go directly to the moon. Instead, the crew will meet up with heavier pieces of their spacecraft in Earth orbit. The elements will connect, then head off to the moon. The separation of crew and cargo will allow NASA to send the components that will enable us to stay longer than we did during the Apollo program. This will allow us to eventually accomplish our goal of establishing a human presence on the moon. The CEV will also carry more fuel and have better computers than Apollo, allowing all 4 astronauts to go anywhere on the face of the moon while their spacecraft remains in lunar orbit in autopilot. And when CEV returns to Earth, it will most likely land on dry ground rather than land in the ocean like the Apollo capsules did. Will the same type of vehicle be used for future Mars missions?
NASA tried to design a family of vehicles that we could accomplish all of our objectives in space. So we picked a shape for the crew exploration vehicle that we thought would be able to basically accomplish the mission of going to the moon and onto Mars. We'll utilize a building block approach. We will make some modifications to the design when it comes time to go onto Mars, and we'll incorporate some more advanced technology, but we'll keep the same basic design concept.
So what are the first steps to achieve this vision?
Well, the first step in the vision for space exploration is actually to continue flying the shuttle safely until around 2010. We're going to complete the assembly of the International Space Station, and we're going to use the space station to do a lot of research in space to understand how things work in space, and that's going to enable us to develop the capability to eventually go to the moon and sustain a human presence on the moon so that we can understand how to live and work in space and then accomplish our goal of eventually sending humans to Mars. All of this fits within our vision of exploring the universe, understanding the origins of life, and using what we develop for space technology to benefit people here on Earth and make our lives better.
This current design is considered by many to be at least 10 times safer than the space shuttle, primarily due to its inline design and launch abort system. Should conditions warrant, the spacecraft and crew can separate from the upper stage of the launch vehicle and make a safe landing on land or in water. Another design change from Apollo that is being explored is the use of an airlock on the surface of the moon. During the Apollo missions, the astronauts would frequently complain about the excessive amount of lunar dust inside the vehicle. The new vehicle may have a separate airlock that will allow dust to stay in a confined space while astronaut quarters remain clean. Coming up, we will revisit the Viking mission to Mars. But first, did you know that every year the moon moves farther and farther away from Earth? According to the leading theory, shortly after Earth was formed some 4.5 billion years ago, a large object the size of Mars slammed into it. This massive collision did several things, including giving the Earth its spin, defining its equator, and also putting enough material into orbit that would later form into the moon. During its early life, the moon was only about 14,000 miles from Earth. By using the Earth's rotational energy, the moon propels itself higher in its orbit, constantly moving away from us. Today, the moon is about 280,000 miles from Earth and is continuing to move away at a rate of 1.5 inches per year.
In the summer of 1976, the first spacecraft to land on another planet landed on Mars. NASA's Viking mission was a historic feat that paved the way for all future planetary missions to come. Here's Brad Breckenridge with more on this incredible achievement.
In the early days of the space program, many at NASA dreamed of extending our reach outside of the boundaries of Earth. One dream in particular was to send a spacecraft to another planet to determine if life existed beyond Earth. This is where the idea for the Viking mission was developed. This extraordinary mission was not only designed to land on the surface of Mars to do basic research, but to also perform scientific experiments to search for life on the Red Planet. Planning for the Viking project began on November 15, 1968, but the actual missions didn't launch until August and September of 1975 due to the complexity and challenge of the project. The mission included 2 identical spacecraft, each consisting of a planetary lander and an orbiter. Their primary mission objectives were to obtain high-resolution images of Mars, determine the composition of the Martian atmosphere and surface, and most importantly, to conclude if life existed. In the summer of 1976, both Viking spacecrafts arrived at their destination. As they eased into orbit, onboard cameras began scanning for potential landing sites. After a favorable landing location was chosen, each lander separated and descended to the planet's surface. The landers touched down over 4,300 miles away from each other, making history by becoming the first mission to land spacecraft safely on the surface of another planet.
Well, when we landed on Mars, I was quite jubilant, especially jubilant when I knew after the second landing that we had 2 relatively successful landers. In fact, the experiments on both landers worked beautifully.
Before the Viking mission was ever launched, many people thought Mars might harbor abundant plant life and microbes living among its rust-colored rocks. But the 2 landers quickly dispelled these notions. The landers revealed a world seemingly devoid of life at all. In an attempt to conclusively prove or disprove life on Mars, the 2 landers conducted 3 biology experiments by remote control from Earth. One of the experiments, called the Labeled Release Life Detection Experiment, collected soil samples that showed signs of possible microbes, but the consensus of scientists interpreting the data believed that the findings did not prove that life existed on Mars.
We guaranteed it for 90 days, 3 months, and I think the lander landed and operated successfully for about 6 years, which was quite a surprise to me because I was familiar with the failure rates of parts. And it turns out that once a few failed, as they did on the way to Mars, when we got to the surface, we were relatively lucky and had very few failures thereafter.
Together, the 2 landers accumulated 4,500 up-close images of the Martian surface. They also collected more than 3 million weather-related measurements, including the first on-site observations of a global Martian dust storm. The 2 orbiters circling high above the planet snapped 52,000 images covering 97% of the Martian globe.
I was very thankful that I came to Langley. Those spacecraft were successful not because of me. They were successful because we had such a tremendous pool of talent here at the field, and I hope that can continue into the future. I believe research ought to go on. It's the best way to get your money back. You can't spend too much for research.
The data retrieved from the Viking mission exponentially increased our knowledge of Mars. Volcanoes, canyons, craters, and evidence of surface water for the first time became apparent from the orbiter images. The Viking mission proved to be one of the most successful missions in NASA history, forever changing our understanding of Mars. In fact, it's been said that scientists learned more about Mars in the first 5 minutes of the Viking mission than in the 500 years before it.
Other Mars missions have also been very successful, including the Mars Pathfinder, the Mars Exploration Rovers, Mars Odyssey, and the Mars Reconnaissance Orbiter, to name a few. NASA is planning more trips to the Red Planet to help increase our knowledge for future human missions. Up next, we'll look at another spacecraft headed to Mars called the Phoenix Lander. But first, did you know that 1 month and 1 day of the week are named after Mars? Today, New Year's Day is on January 1st, but it hasn't always been that way. From Roman times, March had the honor of beginning the new year because it was seen as a time of renewal, when the cold gave way to spring. March was named after the god of war because warmer temperatures and melting snow allowed the Romans to start up their battles in full force again. The day of the week, Tuesday, is also named after Mars. Ancient Babylonians first created the week, dividing it into 7 days. Each day was named for one of the 7 known moving bodies in the sky: the Sun, the Moon, Mars, Mercury, Venus, Jupiter, and Saturn. The Babylonians believed that each of these heavenly objects influenced people's lives on the days named for them. Mars Day was Tuesday. Because of the planet's red color, the Babylonians associated Mars with aggression and performed special ceremonies on Tuesdays to avoid the fearsome influence of this warlike planet. So how does Tuesday and Mars relate? In English, Tus was the name of the god of war.
Mars is a unique and intriguing planet. Although it's now seemingly barren, many scientists believe that at one time it had similar features of our own planet. In recent years, NASA has had great success in uncovering some of the mysteries of Mars, but much more needs to be learned. One of the most important mysteries still to be solved is whether there are in fact large amounts of water ice below the surface. Recent satellite passes by orbiters over Mars have hinted to this, but more definitive proof needs to be found. This is one reason NASA is sending the Mars Phoenix lander to the Red Planet. This new lander will have the ability to dig down several feet through the soil to determine if water ice is present. Here again is TONYA St.ROMAIN, who spoke with Dr. Peter Smith of the University of Arizona about this new lander.
In the past few years, NASA has sent a variety of robotic missions to Mars in the hopes of better understanding the Red Planet. Of the many discoveries that have been made, one of the most important is the detection of water ice throughout large regions of the northern pole. This is important because most scientists believe that if life does exist on Mars, it will be in areas with high water concentrations. To help further our understanding of water and potential habitability on Mars, a new mission is being developed by NASA and the University of Arizona called the Phoenix Mars Lander. Phoenix will land in the northern region of Mars where evidence of ice-rich soil has been detected. This mission will use proven technologies to help unlock the mystery of Martian water and may help us determine the biological potential of the Arctic soils. I spoke with Peter Smith, principal investigator for the mission, to help us find out more.
The Phoenix mission is an attempt to land on Mars and understand a polar environment for the first time. We're hoping to understand the history of water, and we are looking for evidence that life could potentially be living in this kind of an environment where ice and soil are closely together over long periods of time.
Peter, what are the mission's science goals?
The discovery of ice in the polar regions has given us an opportunity to perhaps find the large reservoir of water that's been searched for many years on Mars. So it's a really exciting opportunity for us to go as quickly as we can back to Mars and dig down to this ice that's been seen from the gamma-ray spectrometer that's in orbit around Mars, to understand the chemical and physical properties of the ice and the soil that's associated with it, to understand